Hello everyone. Today we will discuss about programmable interval timer, which is known as PIT, which is very important in your programming interfacing devices section. And now for this we will go with the introduction to 8253 and 8254. 8253 8254 timer. Timer description and initialization. PIT stands for Programmable Interval Timer. The 8253 chip was used in the IBM PC XT and but the starting with the IBM PC AT. The 8254 was replaced the 8253. 8253 and 8254 have exactly the same pinout, and 8254 is a superset of 8253. Now the programmable interval timer, which is 8254. 8254 programmable interval timer consists of three independent of 16-bit program counters timer. Each of these counter is capable in the counting of binary or BCD with the maximum form frequency of 10 MHz used for controlling the real-time events such as real-time clock events, counter and motor speed, usually decoded at the port address 40H and 43H. This works from these four parts from 40 to 43 hexadecimal and has a following functions: generate a basic timer interruption that occurs at approximately 18.2 Hz, cause the DRAM memory system to be refreshed. DRAM stands for Dynamic Random Access Memory, providing the timer source of internal speaker and other devices. Pin diagram. Here from pin number 1 to pin 8 we have data D0 to D7. There are 8 data ports from 1 to 8. Then in the 9 port we have clock 0, out 1, get 0. In the 9, 10 and 11 we have 0 counter, which have clock 0, out 0 and get 0. In 12 port we have the ground, and in 24 port we have the VCC, that means which is the voltage supply. In the 22, 21 and 20, in this 23 section we have the right part, and the bar denotes that it is signal low. That means when the signal is low, then the right works. Then 22 number is for read section. 21 is for control sequence or control segment. Then 20 and 19 is A1 and A0, which is for the selection port. Now the 18, 17 and 16 are for clock 2, out 2, get 2, which is known as counter 2, and 15, 14 and 13 is for clock 1, get 1, out 1, which is for counter 1. Then here we can see the block diagram of 8253. Here counters and output ports. Here clock is the input, get is the input, and out is the output, which is counter 0. Clock is input, get is input, and out is the output, which is clock 1, and this is the same for clock 2. Here CS is for chip selection, which is connected in the bottom of 8253 and which is also a read low function. In the read and write section, those are also active low. That means that when the signal is low, that then they will occur. And D7 to D0 is for data interfacing. This is the block diagram and this is the pin diagram of 8253. 8254 functional descriptions. Here is the pin out for 8254. This is all same to the 8253. Here we have data, counter 1, counter 2 and counter 3. Now here is the read write section, and here is the chip selection, the VCC and the ground section. Here we can see the internal structure of 8254, which is very important for your exam view. Here in the middle we have an internal bus, and then in counter 0 we have clock 0, out 0 and get 0. In counter 1 we have clock 1, out 1 and get 1. In counter 2 we have clock 2, out 2 and get 2, which are bidirectionally connected with the internal bus section. Then we have the data bus transfer, where we have the D0 to D7, which is bidirectional and connected with the internal bus. Then we have the read write logic, where we have the read logic, the write logic, the address section and the chip selection to enable the read write logic. The read write logic generates a logic and move it to the control word register. The control word register is also connected with the internal bus. Then the control word register generate a pulse and send it to the counter 2, counter 1 and counter 0 for this works. That's how the internal structure works of 8254. Now moving to the next. Pin description of 8253 and 54. Here inside the 8253 and 54 timer there are 3 counters. Each of the timer works independently and programmed separately. Each of the counter is associated and assigned as an individual port address. The control register common to all 3 counter and has its own port. Here the CS is for chip selection, because it is active low, so when the input is 0 then the chip selection is active, and when it is 1 it is disabled. Now the address selection A0 and A1, when the input is 0 0 that will select 0 and counter 0. The 0 is for counter 1, 1 0 is for counter 2 and 1 1 is for control register, and if the chip selection is 1 then it is not selected. In the exam point of view, the internal structure is very important, and right after that the block diagram and then the pin diagrams are important for exam point of view in 8253 and 8254. This diagram of chip selection is also very important for small questions. 8254 pin definitions. A0 and A1 are address input, and select one of those 4 internal registers in this 8454 followings. Now A1 and A0, if those are 0 that will select counter 0, 1 is for counter 1, 1 0 is for counter 2 and 1 1 is for control register or control word. Now the clock section. The clock input is the time source for each of the internal counters. It often counted the pulse clock signal for bus controllers. Now CS is for chip selection, which enables 8254 for programming, reading and writing counters. Now G stands for the gate. The input controls the operators of counter in the same mode of operations. Now the clock. Clock is nothing but an input clock frequency which is range from 0 to 2 MHz for 8253, and for input frequency its high is 2 MHz. 8254 can go as high as 8 MHz. Then the output can have square wave, one short and the other square shape of wave in various duties. Now get is the pin is to enable or disable the counter. So in a short we can say that get is to enable and disable, out is the output and clock is the pulse. Now D0 to D7 is the data bus which is bidirectional and easily connected. Read and write are connected to I/O read and I/O write. Input output read and input output write control signals of the system bus. Initialization of 8253 and 54. Each of the three counters of 8253 and 54 must program separately. 8253 and 54 must be initialized before it is used. Now 8254 pin definition. Ground. GND or ground is connected to the system, the ground bus. Out, a counter of output of waveforms. Read is to cause the read generator, which is connected with the I/O read signal. VCC is the power supply of 5 volt. The write section is connected with the I/O write to generate the write signal. 8254 programming. In this diagram, this is very important for your questions. Here we have 8 segments from 0 to 7. The 0 is to select the BCD. M1, M0, M1 and M2 is to select the mode from 0 to 5. That means there are 6 modes. Read, write 1 and read, write 0. There are 2 segments for read, write control. The 0, 0 equals to counter latched command. 0, 1 for read, write the least significant bit only. 1, 0 to read, write the most significant bit only. And if the signal is 1, 1, then the read, write both will occur at the least significant bit first, then it will go through the most significant bit or byte. Now the SC is the select counter. The SC1 and SC2 is for counter selection, where 0, 0 is for counter 0, 0, 1 is for counter 1, 1, 0 is for counter 2 and 1, 1 is for read back command. This diagram is very important for your exam question view. The control word allows the programmer to select the counter and model of the operation, binary or BCD counter. From this diagram you can decide those type of things. Now moving on to the next. Here we have the same diagram. From here we can see it very clearly that if the first D1 is 0, then it will generate a binary counter of 16 bit. If it is 1, then the BCD, which is 4 decoded. If the M2, M1 and M0 is for the models, if it is 0, 0, 0, then it will the mode 1, then 1 is for mode 1, then 2 is for mode 2, 3 is for mode 3 and mode 4 and mode 5. Here we have the binary inputs. Here suppose we have 1, 0, 1, that means 5, so mode is 5 selected. 1, 0, 0 is 4, the mode 4 is selected. 0, 1, 1 is for mode 3, 1, 0 is for mode 2, 0, 1 is for mode 1 and 0, 0 is for mode 0. And now read write logic. Here we have read write 1 and read write 0. Here if the input is 0, 0, that will generate 0, which is the counter latch operation. Then 0, 1 is for read the least significant bit, 1, 0 is for most significant bit and 1, 1 is for the least significant bit first, then the most significant bit. Then now we go to the SC section. SC is for select counter. If it is 0, 0, then it will select the counter 0. 0, 1 is for select the counter 1. 1, 0 select the counter 2 and 1, 1 is the illegal operation. So this is the diagram for this section. So this is how we can call it. That's how the work of 8253 and 8254 control word format. 8254 programming. Each counter may be programmed with a counter of 1 to FF, that is the highest value, and minimum counter is 1. All mode except 2 and 3 are minimum counters of 2, because in 2 and 3 we have already seen that there are two crosses, so those are selected with the 2 mode, 1 0 and 1 1. Each counter have program control word used to select the way the counter operates. If 2 bytes are programmed, then first is LSB stop the counter, and then the second MSB start the counter of a new counter. There are 6 modes in operation for each counter. Now the control word. The figure shows the 1 byte, that means 8-bit control word of 8253 and 54. D0 choose between the binary numbers divisor of 000 to FFFF, which is the binary input, and BCD from 0000 to 9999, which is the BCD function. The highest number is 2 to the power 16 for the binary and 10 to the power 4 for the BCD. To get the highest count, the counter is loaded with zeros. The D1, D2 and D3 are for the mode selection. D1, D2 and D3 are for the mode selection. The control word is very important for exam point of view, so have a snap of this. The D4, D5 are for the read-write logic, and there are 3 logics: read, MSB, LSB, and LSB first and MSB secondly. Here are some modes of operation. Mode 0 is for interrupt on terminal count. Mode 1 is for programmable one-shot. Mode 2 is for rate generator. Mode 3 is for square wave rate generator. Mode 4 is for software tricked stop. Mode 5 is for hardware strict stop. Have a snap of those modes because those are very important for your questions. We will discuss our further examples with the modes and the other things in our next video. Thank you.